everyone. Welcome to my video lecture. Myself J. Ashwini, working as an Assistant Professor of Mathematics, V.V. Vanni Perumal College for Women, Virudhunagar. In this video, we are going to learn some basics of probability. To begin with, we first know what is an experiment. An experiment is a procedure or a process that can be repeated and that give a well-defined set of possible results. Such possible results are called as outcome. In some experiments, the outcomes can be predicted before the performance of an experiment. For example, when finding the area of the circle, we can use the formula pi r square. For different values of radius r, we can get the different areas of the circle. In some experiments, the outcomes cannot be predicted before the performance of an experiment, but we can know the possible outcomes of the experiment. Such experiments lead to the concept of random experiments. For example, for such experiments are tossing of a coin, or picking a card from a pack of 52 cards, rolling of a die, etc. What is a random experiment is? An experiment is called a random experiment if, when repeated under the same conditions, is such that the outcome cannot be predicted with certainty, but all possible outcomes can be determined prior to the performance of the experiment. The next definition will be trial. Each performance of the random experiment is called a trial. Next, sample space. The collection of all possible outcomes of a random experiment is called the sample space. Next comes the definition of sample points. The elements of the sample space are called the sample points. The event is any subset of a sample space. Example, the toss of a single coin results in an outcome either head or a tail. So the sample space of this experiment is h, t, that is head and tail. Next comes the illustration. Let A, B and C be any three events in a sample space S associated with the random experiment. Let A bar, B bar, C bar be the complement events. Then the following are the occurrence of events and their related set theoretic expressions. So for event A only happens, we have to use the set theoretic expression A intersection B bar intersection C bar. When all the three events happen, then the set theoretic expression is A intersection B intersection C. For none of the three events happen is A union B union C the whole bar or A bar intersection B bar intersection C bar. At least one of the three events happen is A union B union C. Here comes the definition of probability. Let S be a given sample space. Suppose a real number P of A is assigned to certain subsets of S and the set function P should satisfy the following conditions. First one, axiom of positiveness. P of A should be greater than or equal to 0 for all A contained in S. Second one, axiom of certainty. P of S should be equal to 1. Third one, axiom of additivity. That is, if An is any finite or infinite sequence of disjoint events, then P of union Ai equal to summation P of Ai. Then P is called as the probability set function and the number P of is called the probability of the event A. Probability of A can be found by using the formula number of favorable cases divided by total number of cases. Next comes the definition of conditional probability. Let S be a sample space with the probability function P defined on it. Let A and B be two events of S with P of B should be greater than 0. Then the conditional probability of A given B written as P of A given B is defined as P of A given B equal to P of A intersection B by P of B. Similarly, we can define the conditional probability of B given A. The formula for that is P of B intersection A intersection B divided by P of A. The first problem, two dice numbered as 1, 2, 3, 4, 5 and 6 on the faces are thrown. Let A be the event that the sum of the points on the faces shown is odd, and B is the event that at least one number is 1. Then we have to find the probabilities of the following: A intersection B, A union B, A intersection B bar, A bar intersection B bar, A given B and then B given A. We will find them one by one. So for that, first we have to write the sample space S. S equal to, since 2 dice are thrown, the sample space consists of 36 points, 1, 1, 1, 2, 1, 3, up to it will go upon 1, 6. Similarly 2, 1, 2, 2, etc. 2, 6. Then 3, 1, 3, 2, 3, 3, etc. 3, 6. And then 4, 1, 4, 2, etc. 4, 6. And then 5, 1, 5, 2, 5, 3, etc. 5, 6. And then 6, 1, etc. up to 6, 6. Totally this sample space consists of 36 points. In our problem, A is defined as the event of getting the sum of the numbers on the two faces should be odd. So A equal to, what are all the odd numbers here? Possible odd numbers 1, 2 and then 1, 4, 1, 6. Similarly 2, 1, 2, 3, 2, 5 and then 3, 2, 3, 4, 4, 1, 4, 3, 4, 5, 4, then 5, 2, 5, 4, 5, 6 and then 6, 1, 6, 2 won't come, 6, 3, 6, 5. Here 3, 4, 3, 6 also will come. So the cardinality of A will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So cardinality of S is equal to 36, cardinality of A equal to 18. B equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 and then 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. So the cardinality of B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So cardinality of A is 18, cardinality of B is equal to 11. P of A intersection B equal to cardinality of A intersection B by cardinality of S. The common thing happens for both the event A and B, that is A intersection B. First we have to find, that is 1, 2 and then 1, 4, 1, 6, that's all I hope, and then 2, 1, 3, 1 won't come, 4, 1 and then 6, 1. So cardinality of A intersection B will be equal to 6. So for this one we get the answer 6 by 36, which is equal to 1 by 6. P of probability of A intersection B equal to 1 by 6. And the next question is, we have to find A union B. Finding A union B, we have to use the formula P of A union B equal to P of A plus P of B minus P of A intersection B, which is nothing but the addition theorem of probability. P of A will be 18 by 36, P of B will be 11 by 36 and P of A intersection B will be 6 by 36. So adding these three things, we get 23 by 36. So P of A union B will be 23 by 36. P of A intersection B bar. For this, we are going to use the concept of Venn diagram. This is the sample space S, this is the event A, this is the happening of the event B. We are in need of A intersection B bar. First, B bar is nothing but the region outside B. So this is B bar, and P of A, to find this we can use P of A minus P of A intersection B by using the Venn diagram. So P of A will be 18 by 36, P of A intersection B will be 6 by 36, which is 12 by 36. We can simplify this value also. P of A bar intersection B bar. So P of A bar intersection B bar is nothing but P of A union B the whole bar, which is 1 minus P of A union B. By substituting the value of A union B, we can get the answer P of A bar intersection B bar. How these things will be equal can also be get from the concept of Venn diagram. So next we have to find the conditional probability P of A given B, that is P of A intersection B divided by P of B. We can substitute the probabilities of both these values and get the corresponding answer, and similarly we can find P of B given A by using the formula P of A intersection B divided by P of A. So these are the respective answers. P of A 1 by 2, P of B 11 by 36, P of A intersection B 1 by 6, P of A union B 23 by 36, P of A intersection B bar 1 by 3, P of A bar intersection B bar 13 by 36, P of A given B 6 by 11, and then P of B given A is also 6 by 11. The next problem is, a random experiment consists in drawing a card from an ordinary pack of 52 playing cards. Let the probability set function P assign a probability of 1 by 52 to each of the 52 possible outcomes. Let A denote the collection of 13 hearts and B denote the collection of 4 kings. We have to compute the probabilities of the following. So what is the event A is, it is the collection of 13 hearts. So in a pack of 52 cards there are 13 number of heart cards. So P of A will be equal to 1 by 4, and B denote the event of collection of 4 kings. So there are only 4 kings in a pack of 52 cards. So P of B equal to 4 by 52. We have to find P of A union B and P of A intersection B other than these two values. For P of A intersection B, what is the common card in event A and B is, there is at most only one king card in a 32 heart cards. So P of A intersection B will be equal to 1 by 52. For P of A union B, we have to use the formula P of A plus P of B minus P of A intersection B. So the corresponding answers are P of A is 1 by 4, P of B is 1 by 13, P of A intersection B equal to 1 by 52, and then P of B A union B is also 1 by 52. Thank you.